21. How can you handle browser events like mouse hover or keyboard interactions in Cypress? Cypress provides commands such as !sci, trigger, !sci, type, and !sci, real press, to simulate browser events and perform mouse hover or keyboard interactions. You can trigger events on specific elements or simulate global events on the document or window. 22. How do you handle multiple browser tabs or windows in Cypress? Cypress has limited support for multiple browser tabs or windows. However, you can use third-party libraries like !Cypress multitab or !Cypress fixture utils to work around this limitation and handle multiple tabs or windows in your tests. 23. What is the role of the Cypress test runner in the test development process? The Cypress test runner provides a graphical user interface, GUI, that allows developers to write, run, and debug tests interactively. It offers features like real-time reloading, test execution visualization, and the ability to inspect and modify application state during test execution. 24. How can you handle dynamic content or data in Cypress tests? Cypress provides various techniques to handle dynamic content or data, such as using !sci, wait, with a timeout to wait for elements to appear, stubbing network requests, interacting with backend APIs, or using fixtures to serve specific data. 25. What is the purpose of test hooks in Cypress? Test hooks, such as before, before each, after, and after each, are used to define setup and teardown actions for test suites or individual tests. These hooks allow you to perform common actions like visiting a specific page or resetting application state before each test or test suite. 26. How can you generate test reports in Cypress? Cypress can generate test reports by using third-party plugins like !Cypress Machosum Reporter or !Cypress X Unit Reporter These plugins generate HTML or XML reports that provide detailed information about test results, including past and failed tests, screenshots, and error messages. What is the difference between !sci, request, and !sci, root, in Cypress? !sci, request. Is used to make HTTP requests directly from the test, simulating API calls. It allows you to interact with backend services and validate responses. !sci, root. is used to stub and intercept network requests made by the application under test. It allows you to define specific responses or behaviors for these requests. 28. How can you debug Cypress tests? Cypress provides a built-in debugger that allows you to pause test execution, inspect application state, and step through test commands. You can set breakpoints using the !debugger statement or by using the debug command in your test code. 29. What are the best practices for writing Cypress tests? Write tests that focus on specific functionalities and scenarios. Keep tests independent and avoid relying on the state of previous tests. Use descriptive test and assertion names for better readability. Leverage page objects or reusable functions to organize and maintain your test code. Use custom commands to abstract repetitive actions or assertions. Write tests that are fast, reliable, and independent of external dependencies. 30. How can you handle timeouts in Cypress? Cypress has built-in intelligent waiting mechanisms, so explicit timeouts are rarely needed. However, you can use the timeout option in commands like !sci.get, or !sci. Wait, to override the default timeout or handle specific scenarios that require longer wait times. 31. How does Cypress differ from other automation frameworks or tools? 1. Cypress is a JavaScript-based end-to-end testing framework that operates directly in the browser. 1. It provides a unique architectural approach where it runs in the same context as the application, allowing real-time reloading and fast feedback. 1. Unlike traditional frameworks, Cypress doesn't require external drivers or APIs and provides automatic waiting for DOM elements. 32. How do you handle asynchronous behavior in Cypress? 1. Cypress offers built-in commands to handle asynchronous behavior effectively. 1. For waiting on elements or network requests, we can use sci, wait, sci.get, should, and sci, intercept. 1. For handling promises and chaining commands, we can use sci, then, sci, invoke, and sci, wrap. 1. Additionally, Cypress automatically waits for commands to resolve before moving to the next one, reducing the need for explicit waits. 33. How do you handle authentication and authorization in Cypress? 1. Authentication and authorization can be handled in Cypress by simulating login actions, storing tokens in local storage, or using authentication APIs. 1. We can log in with credentials using sci, request, or custom commands. 1. To maintain the session, we can store tokens in Cypress variables or cookies. 1. Custom commands can be created to encapsulate authentication logic and reuse it across multiple tests. 34. How do you write efficient and maintainable Cypress tests? 1. To write efficient and maintainable tests in Cypress, it is recommended to follow best practices such as using page objects or reusable custom commands to encapsulate interactions with the application and reduce duplication, organizing tests into logical test suites and separating concerns, using fixtures or test data generators to generate meaningful and diverse test data, employing hooks like before each, after, and after each to set up and clean up test data or perform common actions, using descriptive and meaningful test and assertion names to enhance test readability. 35. How do you integrate Cypress tests into a C/CD pipeline? 1. Integrating Cypress tests into a C/CD pipeline involves the following steps. Set up a headless mode configuration in Cypress to run tests in a C environment. Generate test reports in a suitable format, e.g., JUnit, HTML, for better visualization of test results. Trigger the Cypress test execution as a step in the C/CD pipeline, ensuring proper dependencies are installed. Manage test execution concurrency by parallelizing tests across multiple machines or containers. Integrate with popular C/CD tools, e.g., Jenkins, Travis C, GitLab C, by adding the necessary configurations and scripts in the pipeline configuration file.